Using 1 and 2, you can make two numbers, 12 and 21. But if you just want to have a group which contains both of them, then the group is only 1. That group contains both 1 and 2. That's it. Whether you call that group 12 or you call that group 21, the group is having both of them. It is just one group which contains both the numbers. Within a group, we don't bother about who is coming first, who is coming second. All we are interested in is that both of them are present. But when we arrange them, then we really are concerned who is first, who is next. When you make such things, then you are talking about permutations. When you do such things, you are talking about combinations. That's the difference between permutations and combinations. Suppose I have 11 players in a team. If I have 11 players in a team, that is just one team I have which comprises of 11 players. That's it. Now, who I will call first, who I will call next, that is about arrangement. So just imagine how many ways you can arrange 11 things. And as far as group is concerned, just one group which comprises of 11 things. Let me give you another example. Suppose you are given A, B and C and you have to make a team of just two, just team of two. Then you will say, okay, I will pick up A and B, I will pick up B and C, I will pick up C and A. That's it. Who is first, who is second, who is bothered? It's a team of A and C, it's a team of B and C, it's a team of A and D. But now when we start talking, that order is also important. Maybe in this team, who will come first, who will come next? In this team, who will come first, who will come next? In this team, who will come first, who will come next? The moment you start doing that, you start talking about permutations. Permutations are about order, and combinations are not about order. Combinations are just about group. That is the basic idea of the two terms. In this topic, we will start with law of counting, fundamental law of counting, and then we will go in detail about permutation and about combination. What is the law of counting? Suppose you want to go to C via B. To go to B from A, there are different ways. Maybe one way is by air, other way is via road, and third way is via ship. From B to C, there are just two ways, by road, by air. Now, how many choices do you have to go to C? How many choices do you have to go to C? So you will say this is one choice, air-road combination, air-air, road-road, third, road-air, fourth, ship-road, 5, ship-air, 6. The same task of counting 1, 1, 1, 1 can be done in a much smarter way. This can be done in 3 ways. That can be done in 2 ways. If one task is done in certain number of ways, and if the other task is done in certain number of ways, and the two tasks are independent of each other, they are independent. Nobody is putting a condition that if you travel by road, then you will have to travel by road. No such condition. So if the two tasks are done in certain number of ways, and if they are independent of each other, then the total number of ways of doing the whole job, which comprises of these two tasks, is obtained by multiplying the two. 3 into 2. Going from A to B and going from B to C, these are independent activities. Now, if you go from A to B, you cannot go via air and road both. To go from A to B, you cannot go via air and road both. It's not possible. But to go from A to C, you can go via air and road both. Of course, in pieces. Sometimes air, sometimes road. When you have such options that you have to make one choice, you can't have both choices, then we use the words mutually exclusive. Mutually exclusive means you can't have all. You will have to choose something. So here we are talking of mutually exclusive events. Going by air is an event. Going by road is an event. You can't have both. But air, road, yes. They are independent of each other. From B to C, you can't go by road and by air, both. You will have to make a choice. When you make a choice, it is mutually exclusive. So fundamental law of counting is that if one job is done in certain ways, then it is obviously mutually exclusive. Other job is done in certain ways, then they are obviously mutually exclusive. And these are independent. You multiply. I gave you a simple example because you could actually count 1, 2, 3, 4, 5, 6. This can be made bigger and bigger. Generally speaking, m ways, n ways, total number of ways are m into n. But to get m, we had to add. We did not multiply 1 plus 1 plus 1, 3. 1 plus 1 plus 1 plus 1 plus 1, m. 1 plus 1, 2. 1 plus 1 plus 1 plus 1 and so on up to n. So sometimes total choices are obtained by addition. Sometimes total choices are obtained by multiplication. When are choices obtained by addition? When it is mutually exclusive. So for this task I had to add. For this task I had to add. But when I dealt with independent tasks to get the overall job, I had to multiply. Addition and multiplication are two well-known techniques in permutation combinations and probability, which you will see later. Addition and multiplication. Two techniques applied under different situations. Any questions about this? Let me know. You see, servants can be sent at different times. And the same servant you can send to friend number 3 also. That servant comes back and then that servant goes to friend 1. So you can use the same servant repeatedly at different times. Now, think about this friend. In how many ways can you send him the card? You ask Mr. A to go to him or her. Then you ask Mr. B, or you ask C. You have got 3 choices. But as I said, they can go at different times to others also. Yes, now I can see correct answer. So you don't lose any choice. You have 3 choices with you always. This also 3 choices. This also 3 choices. M ways, N ways, T ways, R ways, Q ways, S ways. So the total job can be done in 3 to the power 6 ways. I think on simplification it should come out to be 729. If you have any questions regarding this, then let me know. Yes, I can see no problem with this question. So if you choose this door to enter, you have 7 choices left. So your first choice is 8, 1 out of 8. Second choice will be 7 only. 56 ways. Any questions? Let me know. So 120. Let's see. 3, 4, 5 post offices and 4 parcels. Parcel 1, parcel 2, parcel 3, parcel 4. Now, a post office has got no limitation. If you want, you send all parcels to one post office, the same post office. So, parcel 1 can be sent here, 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 here. Parcel 1 has got 5 choices. Even if you make one choice, second parcel can also be sent to that same choice. Second will also have 5. It's not like the door type of problem that choices became less after one choice was made. It's not like that here. So 5 remains 5. Third parcel also has 5. Fourth has 5. That's it. And it is registered post. That's why somebody has to go to the post office. 625. If there is any question, then let me know. Three rings, each will have which digits? 0, 1, 2, up to 9. 10 different letters. 0 to 9 are 10 different. 0 to 9, 0 to 9. Out of these 10 digits here, only one digit is correct. Only one digit is right, other 9 are wrong. If you think like this, 9 into 9 into 9, there will be a problem. Because all of them don't, yes, that logic is better. Because all of them don't have to be wrong. All of them don't have to be wrong. Please note this point. To get it wrong, even if one is wrong, it's a gone case. This logic says that this will be wrong, this will be wrong, this will be wrong. So this logic should go. Let's talk about getting it right. I'm in total choices, 10 choices, 10 choices, 10 choices. They are independent choices, so multiply. And out of the total choices, there can be only one right. Only one is right. Only one is right. Any questions? Let me know. I gave an earlier introduction to the meaning of permutations. In permutations, you are not only interested in a team, but you are also interested in the placement of players in the team. How placement is done, who is where, or who will go first, who will go next. Placement, order, location. Suppose we have A, B, C. We have to choose two of them, but not only choose, we have to decide first, second. As far as just choosing is concerned, choosing two, making a team of two, pick up AB, pick up AC, pick up BC. You can do it in just 3 ways, 3 combinations you will get. But if you are interested in placement, relative placement, it could be A first, B next, it could be B first, A next. A first, C next, C first, A next. B first, C next, C next, C first, B next. Each one of them is called a permutation. So totally you have got 6 permutations. Generally, when we do problems on numbers, then generally it is about permutations. When we talk about arranging alphabets, spelling, words, then normally those problems belong to permutations. So when you see problems based on numbers and words, then most of the times they are belonging to the permutations part. Combinations would mean that just team you are interested in. You will decide later, if at all, who will go first, who will go next. This method is simple if you look at small numbers. Just 3 numbers or let alphabets were there. But when the number is large, then this type of counting becomes tedious. Now suppose we have the same question, A, B, C, D, E, F, G, H, and so on. Now choose 2, and not just choose, place in order. Then the job becomes bigger and bigger. So you will start with A, B, A, C, A, D, A, E, A, F. You will go up to A, Z. Then you will reverse the order. Then you will say it could be BA, it could be CA, it could be DA, it could be ZA. Then you will pick up B. You will start with B then. B with A has been considered, so B with C. You will say BC, BD, BE up to BZ. Then you will reverse the order. You will say CB, and then you will say DB, EB up to ZB. Then you will go down to C. You will say with C, A has been grouped and B has been grouped. So with C, you will start with CD, CE, CF. It can be done, but the process becomes lengthy. What we intend to do in this discussion of permutations is to make it quick. We are going to arrive at some standard results using which you can answer these questions very quickly. If I have 26 alphabets and I want to take 2 of them at a time and I want to arrange them also, then in how many ways can I do it? The answer will be very quick once we do that here. Any questions about understanding the meaning of permutation? Then let me know. Let me give you a simple question. Suppose I give you A, B and C. You have to take all three of them, and you have to place them in order, first, second, third order type. How many ways can you do it? 6. 6 is the correct answer. A first, B next, C. Then A, C, B. B, A, C. B, C, A. C, A, B. C, B, A. Let me make it 4. A, B, C and D. And you want 2 at a time. And you want to arrange also. Not just make a team, but arrangement also. How many arrangements or how many permutations can you get? A with B, A with C, A with D, B with C, B with D, C with D. These are the teams. So looks like we are able to get 6 teams. Now, shuffling. AB, BA. AC, CA. Yes, 12 is the correct answer. Now try this. Suppose you have three things. One is apple, other is apple and banana. Apples are identical. There is absolutely no difference. Okay. In reality, it's hard to find such apples, but you assume that they are absolutely identical. You can't differentiate. The question is, how many arrangements can you get? You have to place these three fruits on a line. No triangle or any other shape. Straight line. You have to place them. How many ways? You're getting 6. Let's see. AAB, ABA, BAA. Can you tell me anything else is possible? Nothing else. 3. 3 is the answer. Whenever you have same objects coming more than once, the choices become less. This topic is about choices. Larger combinations, larger permutations, larger choices. And if you have similar things more and more and more, choices become fewer and fewer and fewer. If I offer you 10 apples which are absolutely identical, I ask you to choose one of them. What will you say? What choice do I have? Only one choice. They all look alike. So identical things, if they are more and more, the choices are fewer and fewer. 10 blue pens. Take a blue pen, one choice. 10 identical blue pens. Choice is only one. So there will be different situations that you will face. One is that when things are all different, and in the other case, some things may be similar.